This mechanism is a Friedel Crafts acylation. So we're going to add an acyl group. The carbons attached to it can vary, but this is another electrophilic aromatic substitution. So we're going to substitute on benzene and replace a hydrogen with some new group. And it follows all the same conventions as before. You need something to make a really strong electrophile. So our benzene normally not very reactive, but if you mix an acyl halide, which is pretty reactive, with aluminum trichloride, then you can make a really good electrophile for the reaction that's going to act as our electrophile and do a substitution on benzene. So to start the reaction, the aluminum chloride and the acyl halide will react, essentially making carbocation here. It's mixed with the deprotonated, or it looks like an aldehyde now, but our carbocation here and AlCl4. To make the mechanism a little bit easier, I just start with the carbocation there. And then it's a lot clearer what's going on, and the nucleophile, our benzene ring, will seek out this now strong electrophile and start the substitution. So that electrophilic addition step goes first. I recommend drying both hydrogens, even though we're only going to use one of them. And then, so our electrophile is added on there. We need to remove this hydrogen and get back to the aromatic ring. We can use AlCl4 to do that. So we're going to take the chlorine and its electrons, add them to the hydrogen, leave the electrons behind to reform the pi bond. And this is the acylation reaction then. So there's the Friedel Crafts alkylation, doing really the same mechanism but without the double bonded oxygen. So the acyl halide is this functional group, and when attached to a ring or another structure, this group here is kind of what we refer to as acyl. It shows up a lot in biochemical and sort of biological body reactions where things will add an acyl group and such. The carbon chain could vary, so depending on what we want to react with, there could be other groups other than just a simple carbon or an ethane structure there. But it follows all the same principles of electrophilic aromatic substitution. We need something to make a very strong electrophile, which can then react with the ring, and then do an elimination step to clean it up. That's the reaction.